Okay, let's do this. So what were we talking about? In the last lesson, we spoke about the subject of trigonometry, which was really about the study of triangles. So let me do a little summary before we start. So it really focused on the study of right-angled triangles and how in right-angled triangles, the ratio of sides have particular names. And we used either O, H, and A, or we used Y, X, and R. And we defined these things, these ratios, sine, cos, and tan. And using this, we would find the sides of triangles, or we would find the angles in triangles. So that's a very brief summary of the last lesson. Give me a thumbs up if that's looking familiar to you. Give me a thumbs down if it's looking unfamiliar. Or is there anything from the last lesson you'd like me to clarify before I start today? So that's what we loaded into memory last time. Okay, then let's start today. Now, what you'll notice is with trigonometry, sometimes the triangles seem to get lost. And it's almost like we're in the land of just numbers and algebra. So for example, if we look at this question, it says, find each angle measured to the nearest degree. Now, there is not a triangle in sight. So you may say, well, how are we doing trigonometry if there's not a triangle in sight? Well, basically, the moment you see sine of beta, you don't have to draw it, but you can know that there is a right-angled triangle with some angle beta in it, and the ratio of the red side to the green side will be equal to 0.4848. That's what it means. Or maybe I can even draw it like this. So the sine of beta is equal to, what do we say, the red ratio divided by the green ratio. But we don't need to go into the picture every time. We can use a bit of trigonometric ideas. And what we said in the last lesson, and maybe you can give me a thumbs up if you remember, is I said, look, I have to get to the b, which is trapped inside the sine here. We want to know what b is. So what we do is we apply what's called inverse sine, or the opposite of the sine function. And if we do that on this side, and we do it now, I've run out of space on this side, sorry. Basically, what we end up getting is if we type this into our calculator, we will get the angle B that is hiding in, this is called a trig equation. So I want everyone to put in their calculators this trig equation and tell me what B is. What do you get for B? Or if you're feeling generous with your voice, you can always pop your hand up. That's even quicker. Whatever gets you to communicate quicker. Who feels like they have an answer for B? So welcome to Nico who's joining us. Who else has joined us now? Pila, Tsapang, Nico, Tenda, Otundwayo, Numfundo. Welcome, everyone. Okay, where are my answers? Where are my answers? Okay, Numfundo and Naledi, we have slide 28.99. Okay, round it off. Yes, perfect. Okay, so we've got 29 degrees. So if you basically put in your calculator the sine of 29, you're going to get very, very close to 0.4848. Fantastic. Okay, I want you to do number 3 for me. Can you find the value of A such that the cos of A is 0.7431? Can you please all solve this trig equation for me? What have you got for A? Maybe let me do it on my calculator too, so I don't get FOMO here. Shift, cos 0.7431, and I get 42.003. So essentially I get 40A is equal to 42 degrees. So the answer to this trig equation is 42 degrees. And I see that Gundo, Naledi, Bukhle, you're all good. Okay, fantastic. Let's do number 6. Can you find what W is such that the tan of W gives me 19.0811? What do we get for that? So we're going to have to use inverse tan to unlock the W. So shift tan 19.0811, and we get 86.9999. So basically we're going to get W is 87 degrees. Okay, so already with trigonometry, we've started to move a little bit away from the triangle. Even though there is a triangle that goes with question 6, we didn't need to have the triangle in front of us to help us solve that. And from what I'm seeing in the chat, things are looking awesome. So let us move to part 2 of today. Now, this is an interesting one. Let's have a quick look at this. Now, I thought trigonometry was all about triangles, and yet all of a sudden, I see a wavy thing in front of me. What is this wavy thing in front of me? And I would love to hear someone's voice. Who feels like they can identify this foreign object in our midst? It's definitely not a triangle, I know that. But maybe someone has an idea about what it is. Have you seen this thing in the wild? Bukhle, tell me, what do you think this thing is?
So I think this would be a function because we
It's a
get
function.
different functions.
Yes, it is. And what type of function is it?
A
Any
sine
idea?
function.
Yes. So it is a sine function. It's definitely not a straight line function because a straight line goes straight and this is curvy. So this is the sine function. Now hold on, where have we seen that word before? We know that sine is a trig ratio in a triangle. But now all of a sudden, the triangle is also a graph. So that needs a bit more explaining. So what I want to say is that, or before we even go to that, do you notice that this graph seems to repeat itself? So this graph is what's called a periodic function. It's periodic because it repeats itself every so often. It's periodic. And what you'll notice is this whole graph is almost cut up into chunks of 90. So there's 90, there's 180. Now where's 270? 270 would be there, and 360 would be there. So it's almost like this graph goes up to 90, or it goes up to, what's the highest value? I'll ask you in a moment. Then the next bit of 90 goes to there. The next bit of 90 goes to 270. The next bit of 90 goes to 360. Now, what is the value over here at the tippy top of the mountain? What is that in line with? You can put it in the chat. You can raise your hand. What is the tippy top of the mountain? It's 1. Yeah. Okay. And what is the bottom of the mountain over here? Okay, so it's just -1. So one thing to be aware of is that the sine function seems to go between the highest point of 1 and the lowest point of -1. And the quick way of writing that is just to write it like this. That says goes from -1 including -1 up to 1 including 1. Or you could write it like this. You could say the y value goes between -1 and 1. So that's just bonus stuff. Okay, now I want to point something out to you. If you look at the time, let's say from 0 to 90, I want to suggest that this graph is positive. It is above the x-axis. Give me a thumbs up if you agree that between 0 and 90, the sine graph looks positive. Well, give me a thumbs up if you agree with me. Give me a thumbs down. Okay. Now let's go for the next 90. From 90 to 180, do you think the sine graph is positive or negative? What do we think? The green bit, do we think it's positive or negative? Well, I think even though it's sloping down, it's still above the x-axis. So why don't you try this? Let's take 120. If you put 120, so put in your calculator the sine of 120. Do you get a positive or a negative value? Because if I look at this thing over here, it looks like to me it's in line with a positive y value. Okay, so can you all see that if your x value is between 90 and 180, and you put it in the sine function, remember this is the sine function, it's still going to be positive. The way I think about it is it's visually above the line. Okay, let's go to the next bit. What about between 180 and 270? Do you think the sine function is positive or negative in that point? So if I go from here down, I can see it's below the line. Okay, let's do the last bit. What about from 270 to 360? Do you think this graph is positive or negative? It's still negative because it's below the line. Okay, now I'm going to show you something miraculous. I want you to go to your calculator and I want you to type the sine of 90 in. I want you to type the sine of 90 in, and I'm going to make a prediction. The prediction is it's 1. Am I telling you the truth? Is the sine of 90 actually 1? Okay, I'm going to make another prediction. I'm going to make the claim that the sine of 270 is -1. Am I still telling you the truth? I am indeed. It's almost like this graph is connected to the values on your calculator. And in fact, it is. Okay, now let us go to the question. It says, for which values between 0 and 360, which value is equal to the sine of 30? So let's go and find 30 on our graph here. So where do I think, okay, that was 60, that was 90. I think 30 is going to be here. So what do you think the sine of 30 is equal to without looking at your calculator? What do you think the sine of 30 is going to be equal to without looking at your calculator? Callan, I think you're onto something. Who else? Does anyone agree with Callan? Let's wait a moment to see if the students of the room. Tapang agrees, Callan. Okay. Now, I think you're quite right, because you can put it in your calculator and see the sine of 30 is half, or you can say, look at this. It's in line with a half here. But you know what? The question says, which value is equal to the sine of 30, and it doesn't have the sine of 30 as a choice. Can you find a value from A, B, C, and D which is equal to the sine of 30? I want you to try and answer it. Now, this is a bit of a toughie, but let's try and do it. Let's see what we can do. Which one do you think it is? What do you think matches the sine of 30? Or what do you think is the same value as the sine of 30? Is it the sine of 150? Is it the sine of 210? The sine of 60? So Pang has locked in an answer. I need you to lock in an answer too. Buchle, Callan, everyone seems to say A. Everyone seems very confident. How do we know it is going to be A? Who would like to describe what their thinking is? Just give us, you don't have to be right, but just give us, how did you feel confident about, how did you work out that A was the correct answer? Is anybody willing to share? Okay. I see, let's have a look there. I see Buchle's hand. Buchle, will you give us a sense of what were you thinking when you confidently declared that it was A? What were you using?
You know, so I'm mixing two things together to get my answer of A. I'm using the
Okay.
Cartesian and the quadrants. So we know in the second quadrant, sine is positive, and
Yes.
the reduction formula in that quadrant is 180 minus x.
Okay.
So
So
in order to get sine of
yeah.
150, we have to say 180 minus 30. So then that's how I know it's
Yeah, you
equal.
know it. Okay, so you've got a bit ahead because you've understood something called the reduction formula, which I'm going to get to later today. But if you just look at the graph, Bukle, is there anything on the graph that tells you that the sine of 150 is the answer? Can you see anything on this graph? I don't know, maybe lost Bukle there. I don't know if you can hear me. But so Bukle, what I was going to show you is that can you see the red line of a half? It cuts in line with 30, but it also cuts in line with 150. And that's why the sine of 150 also equals a half. So I don't know if that was a bit confusing or if people got that, but give me a thumbs up if you understand my visual explanation of why the sine of 30 is the same as the sine of 150. I'll just wait. It's quite tricky, so I want to make sure I leave some time for questions in case anybody else is feeling a bit confused. So all I'm doing is saying, look, okay, so if you are feeling confused, don't worry, I'm going to come back to this. But can you see visually that if I drew a line across, if I go from 0.5, look at this line, everything in line with this line is a half. And the only place that it cuts the graph is at 30. And then the next place it cuts with is 150. So remember, here's 180 over here. Here's 90. There's 270. So I'm just visually reading it off. The other way to do it is to check these in your calculator. So type sine of 210, see what you get. Type sine of 60. You'll notice sine of 330. None of them are equal to a half. Only this one over here. Okay, we're going to come back to this in a later thing. So if you're feeling confused, don't worry. I just wanted to give you an overview. So just to let you know what the basic trig functions look like. And I'm going to explain where they come from later in the lesson. But here's the sine graph, and it goes up to 1 and down to -1. Here is the cos graph. What is different about the cos graph compared to the sine graph? There's some stuff that's the same. There's some stuff that's different. Maybe I should leave them both on the screen so you can see them. Okay, the big difference is the cos graph starts at 1, whereas the sine graph started at 0. It goes down to start with. This one goes up. But otherwise, they look kind of the same. And if I look at the way they're going, they also seem to be going in jumps of 90. It's just that it's almost like the sine graph is a bit ahead, I guess. Okay, so the other thing that's different is the cos graph is positive here, then it's negative, then it's negative, then it's positive. Give me a thumbs up if you notice the difference, whereas before, the sine graph seemed to go positive, positive, negative, negative. The cos graph goes positive, negative, negative, positive. Give me a happy face or thumbs up if you follow my positives and negatives. And if you don't get it, it's fine. Just give me a thumbs down or unhappy face. I want to rather slow down and get you on board. Did not know. Okay. So can you see, though, that the graph is above the x-axis here, and then it's below the x-axis for this period? Whereas this one is above, then it's below, and then it's above. So it has a different, I'm going to come back to this later in the lesson, but it's important you see the idea. Now, what about tan? Oh my goodness. Okay, tan is its own little thing. What I notice is that tan seems to go, it has these discontinuities every 180 degrees. Does anybody know what these things in pink are called? What are these things? Those are called asymptotes, yes. And you'll notice, put in your calculator the tan of 90. I'm curious to see what happens. So put tan of 90 in your calculator. What does it say? What does it say? Does it say happy, sad, a number? It says error. It is error. And the reason it says error is that tan is undefined. It's undefined there. So you may not go there. So it's almost like a warning sign. Don't go there. The other thing about tan that's very different is it doesn't seem to get to the top of the mountain. It just goes up forever and it goes down forever. So that's something to think. And then the other thing is that tan seems to go in two halves. It doesn't go in quarters. Like, the last graph went in quarters. Tan seems to do its own thing. It seems to go like in halves. So give me a thumbs up if you followed that, my visual description of tan. Okay. Now, I want to ask you one more thing. If we have to look at the different regions on the tan graph, can you tell me the pattern you see? Like above we had like positive, negative, negative, positive. What do you think the pattern for the tan function is? Just visually looking at it. Do you think it's negative to start with or positive? Give me a pattern using the using what you have seen of this. Like, do you think the tan of 45 is positive, or do you think the tan of 45 is negative? So I think it starts off positive, yes. And then after this first yellow bit, the pink bit is negative. And then what is the green bit? What's the green bit going to be? It's going to be positive, yes. And then what's the blue bit going to be for the graph? If I look at anything in the blue bit, so like 300, it seems like it would be negative. Now, one of the things I want to point out to you guys is that each function seems to have it's a little bit different behavior. And so we need to investigate this further. Now, I'm not expecting you to understand everything at this stage, but I am expecting you to know how to use your calculator and to be able to observe stuff on the graph. Now, we're almost at the half time for a break, but I just want to do a quick little multiple choice question before we have a break. Okay. This is the question. It says, if sine is negative and cos is positive, then which statement is true? Now, I'm going to give you something to help you with this. And this is a very famous diagram that uses what we learned from the graphs earlier. And this diagram is called the cast diagram. And I just want to explain how it works. So it's a Cartesian plane, and it starts at 0. And if you start measuring an angle, you get to here, you get 90. And if you get 180, you get to there. If you get to there, you get 270. If you get all the way back to here, you get 360. So it's almost like an arm that can rotate starting here. Now, what this diagram is telling you is it's saying this, okay, but the other thing is this is called quadrant 1. This is called quadrant 2. This is called quadrant 3. And this is called quadrant 4. So we go anti-clockwise. Now, what the cast diagram tells you, it says A stands for all trig ratios. So every trig ratio between 0 and 90 is positive. So for example, if I say the sine of 30, I know that will be positive. I don't even have to try it on my calculator. If I get the cos of 30, I can promise you it will be positive because that angle 30 is between 0 and 90, and all trig ratios between 0 and 90 are positive. Now, that's good and well for when everything is positive. But what does it mean when S is there? It means that only the sine trig function or ratio is positive here. The other two are negative. So what are the other two trig ratios other than sine? Well, it's cos and it's tan. So if I go to my calculator, and I want you to do this. What is the cos of 150? I'm going to predict that the cos of 150 is negative because it's in quadrant number 2. If I start from here and I go across, 150 will get me to here. And I'm going to claim it's negative. Nomfundo says her student calls it all students take coffee. So that's the one way of remembering it, yes. What are you getting for the cos of 150? Is it negative or is it positive? I want to see people put it in their calculators and commit. So the cos of 150, who else can give me a Buchle thinks it's negative? Naledi, you perfect. Okay, now, using the same cost diagram, I want you to tell me, what is the tan of 210 going to be? Is it going to be positive or is it going to be negative? Now, 210 would give me an angle all the way around. Is the tan of 210 going to be positive or negative? Oh, okay, it's positive because you ended up in quadrant 3, and in quadrant 3, tan is positive. Okay, one more before we take the break. What is the cos of 330 going to be positive or negative? So where would 330 be? So 330 would be 90, 180, 270, 330 would get me here. And if you type in your calculator, the cos of 330 is indeed positive. Okay, now you have begun to learn the beginning of what's called the cost diagram and the beginning of something called reduction formula. And you've done incredibly well. But in order for your brain to absorb this, you need to take a break. So I want you to join me, like this happy fellow, in turning on your cameras, and I want you to join me in standing up and taking a break. I worked very hard there, you guys. That was difficult work. And so you need to take a break. So I want everyone, cameras on, looking at me, and we're taking 3 deep breaths. Oh, that lovely oxygen. Breathe in again. Okay, one more nice deep breath. And you must breathe in with your nose and out with your mouth. Okay, one more. It's so good. I just have to do another one. I can feel how much happier my body is getting. Okay, I want to get the tension out of my body, so I'm going to shake my arm, get it nice and loose. Shake this arm, get it nice and loose. Shake both arms. Shake your legs. Give them a good shake. Shake your other leg. Shake your other leg again. Shake it out. There we go. Just shake whatever you can. Okay, then let's stand up straight. Let's roll our shoulders back. We roll the shoulders. We can roll them forward. Okay. Then let's do a new one. Let's do a tricep stretch. So arm like this, behind, across the back, and just look out in front. So tricep. And then to the other side. Okay. And then shake it out one more time. Okay, so we've got some of the sort of tightness out of our body. We've got some oxygen. Now we need blood flow. So you know what it's going to be. It's going to be 15 jumping jacks. That's a jumping jack. And we start in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and that is me. My heart is pumping. Let's just say that. And then while we let our heart rates come down, let us try and solve this puzzle together. We're trying to make 24. We need to use all the numbers once. Can you do that? Can you find 24? Oh, I can definitely feel my heart rate went up there. So oh, sure, yeah. Who feels like they can get to 24? This is a blue card, so it's a bit harder. That's a 9. What about not normally 8 and 3 or 6 and 4? You must use all of them, yes. So how can I make 4 times 5? No, I was going to say one way of doing it is 4 times 5 plus 9 divided by 3, but that still gets me to 23, not 24. What about 5 plus 3 is 8. Oh, goodness gracious. I might have to reserve this for another time because we can come back to it, but I can't see it obviously myself. What about 9 minus 3 is 6. 6 times 4, but then I got to use the 5. Okay, I tell you what, take a screenshot, and for the next lesson, you guys can try and find me how to get 24 using this card. If it comes to someone in a flash of insight later in the lesson, that's awesome. But for now, my brain says no go. But maybe it'll come to me later on. Okay, let's go back to our lesson. So, ooh, Sylvester, let's just see. Have you solved it? 5 plus 4 is 9. 9 times 3 is 27. Oh, okay, Sylvester, you were close. You were very close, but no cigar at this stage. But don't worry, we'll come back to it in the next lesson. If you come early to the next lesson, I will put it up at the beginning and we will have another go at it. Okay, let's go back to this multiple choice question. So it says, if sine is negative and cos is positive, which statement is true? So let's clear some of this stuff away because it's a little bit cluttered. And I want to say, we'll do the first one together. So I'm going to draw this, and it says, if sine is negative. Now, if I think about the cast diagram, sine is negative over here and over here, because everything is positive here, everything is positive here. But sine will be negative in quadrant 3. So this is called quadrant 3, and this is called quadrant 4. But it says cos is positive. Now, cos will be positive here and here. If sine is negative and cos theta is positive, then which statement is true? Well, I think the only way both of those statements can be true is if you end up in this quadrant over here, quadrant number 4. Choose the option here that you think matches quadrant number 4. Is it going to be A, B, C, or D? Which one do you think matches quadrant number 4? Now remember, it's 0, 90, 180, 270, 360. So if you are in this quadrant, you have to be greater than 270 and less than 360. So you must be D. Okay, so I want you to try and do number 2 now. So look at number 2 and see if you can give me the correct answer for number 2. If tan of theta is less than 0 or negative, and cos of theta is also negative, which of these 4 options do you think is correct? I'll give you a chance to draw your own cast diagram and to draw some ticks to help guide you. So tan is negative here and here. And cos is negative. Where is cos negative? Oh, cos is negative here and here. Because tan's positive, so cos is negative here and yeah. Now, what quadrant? This is quadrant 2, and quadrant 2 is between 90 and 180. Is there one for 90 to 180? There is. My answer is B. Okay. And it seems like Mfundo, Tapang all agrees. Okay, now, I want you using, okay, wait, hold on. I haven't spoken to you about negative angles. Oh my goodness. Okay. So if we look at angles, this is 0, this is 90, 180, 270, 360. But if we go the other direction, if the angle's going this direction, it's minus 90, minus 180, minus 270, minus 360. Now, you may say to me, hold on a minute. When did we get negative angles? I know it's a little bit ridiculous, but I will get to it in later lessons. So I want you to tell me this, there's a series of trig functions with numbers, and then you have to evaluate them. They are going to be either positive or negative. I want you to evaluate each of these and tell me if they're positive or negative. And then I want you to put your combo, your 4-thing combo. Like if you would think all of these are positive, you put plus, 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 plus in the chat. If you think it's negative, positive, you put that. But I want you to work out whether you think these are positive or negative using the cast diagram. And then I'll wait for your thing in the chat there. So where is 315? 315 would get me into this quadrant. And you have to ask yourself, is sine positive or negative? Now, where is minus 215? Minus 215 would get me into that quadrant. So that's the blue one, and then this one was the green one. What about the red? Okay, 215. 215 gets me into that quadrant. And where's 390? Oh my goodness. So 390 is the whole way around. Sorry, it's looking a bit crazy. And back into that quadrant. So this one is going to be negative. This one is going to be negative. 215 gets me in quadrant 3, so that's positive. And 390 is in quadrant 1, so it's positive. So you get negative, negative, positive, positive. Okay, guys, you are getting the cast diagram. So all the cast diagram does is it summarizes the behavior of the trig functions. Remember earlier in the lesson, we had the graphs, which showed us the trig functions. The cast diagram just takes the graphs and puts all that information into one simple drawing that we can access. So that's why the cast diagram is so useful and teachers make such a big deal, because it summarizes the behavior of the trig functions very nicely. It's much easier than having to draw 3 different graphs. Give me a thumbs up if you understand the cast diagram, where things are positive, where things are negative. Give me a thumbs down or middle like face if you still feel a bit unsure. Like if I said to you, is the sine of 240 positive or negative? Would you understand what I mean by that? Let the people speak. Let the people vote. Okay, fantastic. All right, ladies and gentlemen. All right. Let's go back to graphing land for a second. I want you to look at this graph. This graph is the cos function. It is the graph y equals cos x. And you'll notice that it starts at 1 just the way cos x is meant to. It says you can use the graph to help you. What is the value of the cos of 120? Now, using the cos using the cast diagram, I kind of know that in this quadrant, it's going to have to end up being negative, don't I? Because I know that in this quadrant, only sign would be positive. So in some ways, once you know the cast diagram, you almost don't even need to look at the drawing. But which option do you think it is? A, B, C, or D? Which one? We can even go and find it on the graph. Where's 120? That's 90. So what's that? That's probably one. So that's probably 120. So it's going to be somewhere in this part of town. It's going to be somewhere over here. So 120 is going to be there. And you can kind of see what's that in line with? It's in line with -0.5. But the other reason you knew is because these are all positive, and this was the only one that was negative. And since 120 is in quadrant 2, the cast diagram already told you what to do. Okay, let's go and look at this one. Okay, this is getting to the reduction formula, so I will skip that for now. Okay, let's finish off with a little bit of a preview. Now, if we want to make things a little bit more exciting, we can start to label the types of angles we get in the different quadrants. So if you are in quadrant number 1, all of your angles will always be theta. If your angles are in quadrant 2, you can write an angle in the form 180 minus theta. Now, this is going to seem a bit like random, so just go with me for the moment. If you're in quadrant 3, every angle can be written as 180 plus theta. And if you're in quadrant 4, every angle can be written as 360 minus theta. Now, you may be asking yourself, what has 180 and 360 got to do with the price of bread here? Like, what is going on? So let me maybe give you another drawing. If you look at this angle, let's say I draw 150 degrees. Okay, so let's say I draw 150 degrees. Are you all happy that 150 degrees ends up in quadrant number 2? Give me a thumbs up if you're happy that 150 is up to there. Now, if you imagine 150 as the angle you start with, but now imagine that you drop a perpendicular line down here. What is the size of this green dot over here? Could you work out what the size of that green dot is without anything more? Except, can you tell me what the size of the angle where the green dot is? So because we know a straight line is 180, Callan is quite correct, Nomfundo is quite correct, that is 30. So what this diagram is saying is that you could rewrite 150 as 180 minus 30. So it's saying, look, 150 is in quadrant 2. You can write it as 150, but you can also write it as 180 minus the green dot. So you can think of it as almost like you can have the red one, or you could have the blue one, and then you go backwards by the green amount to get back to the same place. And if you can say that, you can also say the sine of 150 is equal to the sine of 30. Oh, sorry, let me actually not even say that. Let me just say the sine of 150 is the same as 180 minus 30. Give me a thumbs up if you agree that the sine of 150 is the same as the sine of 180 minus 30. We'll get to 90 later on, but for today, I just want to introduce what's called the horizontal. Okay, now, when we use the cast diagram to do the reduction formula, we do not like to write it with obtuse angles like 150. We always rewrite them in terms of the nearest horizontal if we can. Or we use these formulas over here Like in quadrant 1, 180 minus theta, quadrant 2 is 180 plus, quadrant 4 is 360 minus. But let's do a little practice one. I want you to rewrite the tan, okay, the tan of 210. I want you to write it in terms of the formula that is in quadrant 3. So rewrite the tan of 210 in terms of what's called the reduction formula in quadrant 3. What do you think I'm going to rewrite tan as using that formula? It is just going to be 180 plus 30 because it's the same as 210. Exactly, exactly. Okay, well, let's not leave out quadrant 4. It's probably feeling a bit left out here. Let's say I give you an angle that goes all the way around to here. I'm going to call this angle 330. Or let's say I put it, let's not put the 330 there to be confusing. Let me put the 330 down here. I want you to rewrite the cos of 330 in terms of this formula for quadrant 4. So Buchle, we're not getting to reduction quite yet. We're going to talk about positives and negatives soon. But for tonight, all I'm doing is I'm rewriting this. So be careful. It's going to be 360 minus 30. So it's almost like I go all the way there and I go back again. So basically, if I want 330 and I have to use that formula, I get the cos of 360 minus 30. Okay. Now, I think that is a good place to end for today. Basically, what we did today is we looked at trig ratios being positive and negative in different places. We looked at trig graphs, and we looked at the beginning of what's called the cast diagram.